Hello and welcome to my channel. So let's continue talking about the stock problem, which is 1, 2, 3, best time to buy and sell stock tree. This is today's daily challenge question. So the question is similar to the problem we solved yesterday. You are given an array of the integer, which is representing the stock price, and you need to calculate the maximum profit. But in this question has some difference is you may complete at the most two transactions. So you can at least at most buy and sell stock twice. And also you may not engage in multiple transactions simultaneously. So um, so the example is similar. For example, if the price given this price list price series, then maximum profit we get is 6 because we can buy on day 4 and sell on day 6, then buy again on day 7 and sell on day 8. So add these two profit together will be 6. So the question uh, this type of question is similar to the other stock question. We can use the dynamic programming. So firstly, we want to define the state. So let me draw some like state graph. So firstly, we have a state without a stock. We can call it no stock. And the no stock actually it can last multiple times. So actually we can go from itself. There's a self loop. So then from the no stock, if we bought some stock on some day, we just buy. Then we have another state. We can call it like hold one, hold the first time. So hold the first time, we can also have multiple days. So it can uh, also have a self loop. Then hold first. Then next is if next date is if we sold. Then we go to a state we can call it uh, we can call it like a sold one. That's or we can call it like no stock one. So which is a state without stock. So then it also can go like a have self loop to itself. Yeah, and then next state is if we bought it again. So we can call it a hold second time. So that whenever we have buy or sold on the transition, there is a change on the profit. So the hold second time also have a self loop. Then the last one is we sold again, and then we have no stock again. So this one we can call it a sold second time. Sold two. So sold two is uh, like a no stock. We can also have a sell point. So this cover all the situation which can happen in this question. So Yeah, and then we actually it's quite clear that we have five states, so we can mark them uh, individually by 0, 1, 2, 3, 4. So so that we actually can define this dp 2D dp state using the 2D array. We can have like a five states. So in the end, we let's mark this also. We can actually add it to the here. So let's get n. So 0 means no stock. Then 1 is bought and hold first time. 2 is sold after sold first time. 3 3 is similar to 1, which is but only difference is it's bought and sold the second time. 4 sold the second time. Yeah, so this covers the 5 states we need. And also we need to define some um, initial condition. So 0, 0 must be 0. We have no stock, so we don't get any profit. So dp 0, 0, 1 is will be we actually sold bought a stock at this first day. So we with the profit is minus negative, price is 0. The dp02 is we sold the first time, which actually is impossible because the first day we are not we cannot buy stock and sell on the same day. So we can define this as a like infinite, which is an impossible state. Similarly, those 3 and 4 is all impossible on the first day. So yeah, so let's continue. So we already have the initial condition. Now we can derive the transition. So the first on the ith day, how do we get ith 0? So ith 0 will only happen from I minus 1 0, which is no stock condition. So I 1, which is bought and hold the first time, it can happen either I minus 1, 1, or it can happen that the previous day it's still no stock, but this day we bought the stock, so we can have a we minus prices I. So then I2 is the sold first time. So this one also we can have I minus 1, 2. So the state is already 2 at I minus 1 day. Another possibility is I minus 1, we are still having the stock. So, but then we sold on the ith day. So, and also there is 3 and 4, but 3 and 4 is similar to 1 and 2, except they are doing the second time. So the 3 is corresponding to 3, and also here is is 2. So it can only transit from the previous state. 4 is either 4 from 4 or it's from 3. So this basically covers all the transition, 0, 1, 2, 3, 4. So in the end, we just need to return, firstly, we can define this answer. And then we need to return the max of dp n minus 1, 0 to dp n minus 1, 2 and n minus 1, 4. So we can only have a 0, 2, and 4 in the last day to get the max profit. So because if we have stock, we should sell the stock on the last day to maximize what the profit that we have. So yeah, so we can do a loop here. Just increment the I twice each time. So we just update answer, and in the end just return the answer. So the time complexity is O over n. Space is also O over n because we use the DP array. So let's check if, oh, okay, there is something wrong. Outer bound dp, oh, right. So actually it's not n here, it's 5. Yeah. Let's check a few examples if it's correct. Okay. Okay. So this concludes today's exercise. We have used the dynamic programming to solve this question. So if you have any question or comment, please comment on the video. And thank you for watching. See you.